Okay, in this video, what I'm going to do is I'm going to talk you through how you would answer a question in your exam on modelling techniques. Now, before we actually look at an example, there are a couple of slides here that I think it would be worthwhile looking at prior to doing an actual example. On the screen, we've got CAD features that you should know about. You should know how to extrude and to revolve in order to make a CAD feature. It says, for example, to answer CAD questions on modelling techniques, you will need to be familiar with how to produce CAD features. A CAD feature is an element of a CAD model created by adding and subtracting material. Features can be found easily on the modelling tree in Autodesk Inventor. As well as producing CAD features, you also need to know how to edit these features. So CAD edits that you need to know about include shell, fillet and array. So to answer CAD questions on modelling techniques, you will need to know how to edit these features. To edit something is to change it in some way. So let's now look at the next slide, which relates to features and the editing of features. On this slide, for the features and for the edits, what I've done is I've added the information that you need to include in your answer when describing how you would complete the construction of a CAD feature in Autodesk Inventor. So for extrude, when you look at the drawings in the paper, the orthographic drawings, you need to be able to identify the sizes of the extrude that you need, the shape of the extrude, and whether you're adding or subtracting. When it comes to revolving a component to produce a sort of cylindrical component, then you need to be able to identify the profile shape, the relevant sizes, the axis that you're going to use when you're revolving it, and the revolve angle, although in most cases that will be 360 degrees, and whether you're adding or subtracting material. When it comes to editing, in relation to shell, you need to know when to shell the feature, what the shell thickness has to be, and what faces that have to be removed in order to create the shell. When it comes to fillet and chamfer, you need to know whether it's to be rounded or sloped, or what edges have to be filleted or chamfered, and what the sizes are. When it comes to array, you need to know whether it's a box array or a radial array. You need to know the size and shape of the profile, the spacing, the number of times that are required in sort of the columns and rows of the array, and the direction or angle and the sketch or feature associated with the particular array. So let's look at some examples. On the screen we've got an example here. It says, Portal want to expand the range of door handles. They have described an interchangeable design that allows a handle to be removed and replaced. So we've got a sort of rendered, what looks like a rendered CAD model of the handle, and you can see that it's this bit here is the feature that they want you to describe how this feature would be made or produced on Autodesk. So an orthographic drawing of one of the handle components shown below. So make sure that you examine the orthographic drawing and you have a good understanding of its sort of three-dimensional shape and form. So we go to the page here. It says, describe using the correct dimensions and 3D CAD modelling terms how you would use 3D CAD software to model the handle component in the orthographic drawing shown opposite. You may use sketches to support your answer. So we're going to describe how we would make this component of the handle using Autodesk Inventor. So let's have a look at what the answer. So basically, if you look at it, the first thing that you should notice is it's obviously cylindrical. So we know that we can create cylindrical forms by sketching circles and extruding them. So the first thing that we could say is we need to sketch a circle. So the circle of the main cylindrical part of this handle component is this one here. right? And its diameter is 20 millimeters. So you would write down, sketch a circle on working plane to a diameter of 20 millimeters. You would then, after that, you would finish the sketch and extrude to a length of 50 millimeters to create the cylinder. So you can get the length by adding 30 millimeters to 20 millimeters, and that would create that cylinder. Next, we would then select the end of that cylinder and we would sketch a circle 10 millimeters in diameter. So this smaller circle would be sketched on the end of that cylinder. And then once again, using extrude, this circle would be extruded to a distance of 5 millimeters. And that now we're at the stage we've got these two cylinders created on screen. Okay, now to finish it off, we need to take this corner off to create this sloping surface. So to do that, you have to use the origin planes. So we want to explain that. So switch on the feature working plane running through the middle. That's your origin plane. So using the origin plane that runs through the middle, sketch the triangular shape using 30 millimeter and 20 millimeter sizes. So you could, I could sketch this on here. I'll just see if I can. I could sketch this to illustrate that bit. You know, we're trying to create this triangle here. Right, I'm not done that very well, but that triangle there basically is what we need to sketch. And once you've done that, you would then select that triangle, finish the sketch, select that triangle and extrude in two directions, subtracting the material out the way to create that sloping surface. So there is typical answer, clearly explained with all of the information that's required to gain 4 marks. Let's have a look at another question. This one is a wee bit more challenging, but you still approach it in the same way. In this particular example, it says, cone is a portable container for storing earphones and other cable accessories. So you've got, again, some Autodesk Inventor models showing you this portable container, and we've got the associated orthographic drawing with all of the relevant sizes and information that you need in order to model it. So what they want you to do, what component do they want you to model? Tells you here. The lid was modelled using 3D CAD modelling software. Describe with reference to correct dimensions and 3D CAD modelling techniques how the lid can be produced. You must use the drawing provided in the supplementary sheets for use with question 3A. So that's this drawing here, which I've put on the screen. You may use sketches to support your notes. So it's exactly the same as the previous question, but this time it's 6 marks, which kind of does give you an indication that this one is a slightly more challenging feature to make. But you go about it in the same way. We would look at the form, and we need to try and think about what we can do to create that solid form. So in this case, and one of the things to remember with Autodesk is there's different ways of doing it. In fact, if you look at the answer to this question in your SQA website, you'll find that there's 3 different ways in which you can create this component. And you need to, as a student, sort of kind of decide which way that you're going to use that you think you understand best in order to answer the question. So the way in which I've decided to do this is to extrude this bit at the bottom here, and then to draw a profile of the left-hand side from there to there, revolve it to create the solid shape, and then just like in the previous question, use the origin plane to run through the middle and extrude and subtract out to remove the material, so you end up with a slope, and then finally to select the bottom face here and shell it to create this hollow lid to the container. So again, you'll see that the answer here explains this and has all of the information that's required in order to demonstrate that you do know how to model that component. So it says sketch a circle diameter 28 millimeters, so that's this bottom one, and extrude to a length of 3 millimeters. Select a face on this cylinder and sketch a circle diameter 48 millimeters and extrude this circle to a length of 3 millimeters. select the origin plane and sketch a profile on the left-hand side. So that's there. Maybe I would need to add a sketch or something to really make it clear that I'm actually just sketching this profile sort of from there to there. And I would maybe need to add a sketch to highlight that. Revolve the profile around the central axis degrees, 360 degrees. Select origin plane and sketch a triangle as we did in the previous question, and extrude out by subtracting the material, and then select the bottom face to shell to a thickness of 3 millimeters. So that's one way of doing that. Just to show you and make it clear that there are different ways in which we can do this. An alternative way would be to attempt to sketch this whole profile on the left-hand side and then revolve it. And that's you could tackle it that way, and then you would use the origin plane to remove the material to create this slope and then shell it, so that's slightly different. Another way that I showed you in class, which is a useful command, feature command that you can use, is the loft command, and you could describe, for example, that we could extrude the bottom circle here and then extrude the second circle, and then at that point we could loft it from that line to that line, and then loft it from that line to the next line, and then again it's the same idea. Use origin plane to subtract the material to create the slope, and then select the bottom face to shell it. So there's really 3 different ways which you could use to answer this question, but you want to just make sure that when you do the exam that you make a decision what way you understand best and try to explain it. The only thing I would want to finish off here is I would probably add some sketches to this just to make these statements a bit clearer. It's a bit difficult to do this on the computer, but if I was doing this on paper, that's what I would do. Okay, so that's how you would answer these CAD questions. So hopefully that's going to be of help to you prior to you sitting your exam. Okay, thank you for listening.